So for some entertainment, I thought I'd do a video of the progress we've made since the last blog update. Not sure whether this will be a regular thing or not, but we'll try it out. So here's the car sitting in the garage, and we'll go through some of the things I've done to the car since the last update on the blog. So starting at the front of the car, we've got I saw some horns, and these are Heller horns, Supertone. Apparently they're as loud as you're legally allowed to go. And just had to make a couple of spaces to enable those to be bolted on there at the front. Over here at the rear of the car, the radiators needed these upper stays to be fabricated, stop them flapping about. There was a number of different ways I thought about doing this, but I think this turned out to be the best approach. Just look at these braces in a bit more detail. So it's pretty straightforward. You've got a tube that's welded to another tube that's threaded so the bolt holds the whole lot together. The plate at the end is, how much is it? It's 3 millimeters thick. In here there is the peg, aluminium peg sticking up from the radiator, which has been drilled and tapped, and then over that peg you squash down a bit of heater hose, and then over that piece of heater hose you put two smaller pieces of heater hose, and so that the thing becomes fully trapped inside the heater hose. So you've got a rubberized mount, and so it's not going to, the steel plate's not going to, so the steel plate's not going to come into contact with or push directly against the aluminium. And then I just made a aluminium washer to the right size to cap it all off. So this is the one on the driver's side, obviously. Here's the stay on the passenger side. Behind the stay is, or behind the radiator, this large piece of plastic has been 3D printed as a single piece on the big 3D printer. This part is in PETG carbon fibre. I've still yet to make some, I've got to make a bracket to go in here on this top corner off to that bolt, and then I think I need to make something to tie this corner to the frame. Inside the car, most of the plastic needed for the holding the instrumentation is done, I guess. What you're looking at here is the digital dash for things like fuel pressure, air-fuel ratio, water temperature, that sort of thing. Again, that's all printed in PETG carbon fibre. Then over here on the left of that is where some analog instrumentation is going to go. The main one that's missing there at the moment is the speedometer that I've got to buy. There's that plastic in there is in two parts. The part behind it is still a prototype part that was done in PLA on the big printer. You'll notice the gap here, which is where the warning lights are going to go, and that'll be better on the real thing, obviously. Also in the car, you can see I've printed again in PETG, printed the cover that goes over the wiring as it comes out of the side of the car there. Above that you can see the ECU, and I have to design and print another cover to go over that. And down here on the driver's side there is a similar cover for where the throttle cable comes through the side of the car. There's also 3D printed. On the floor of the car, I've now finished the pieces of metal that go on top of the frame rails that the passenger and driver's seat fit on or go on. There's a diagonal tube underneath that which makes it very awkward for your feet, so that needed to be covered up. These bits of metal are held on with 6 screws onto aluminium spacers that are a bit taller than the height of the floor tube and are threaded, so they screw in from the top and they screw in from the bottom, so there aren't any nuts sticking out on the underside of the car. The other thing we've been doing here, as you see on this tripod arrangement, is I'm trying to work out the positioning for the mirrors. You'll see that I have the mirrors quite high, and the reason for that is so that you're going to hopefully be able to see over the top of the rear bodywork to get a better view, and this area above, if you look this way, this area above the front wheel and down the side of the car is where the majority of air is going to go, that should hopefully end up going through the radiator. And if I put the wing mirror low, it's sort of a more orthodox position, then it would interfere with the airflow to the radiator. So these are the mirrors that I bought for the whole exercise. They're an aftermarket mirror from a Holden Commodore VE, and I wanted electric mirrors because I don't have a rear view mirror as such, and wanted to be able to adjust the mirrors from the driver's seat and hopefully be a bit safer as a result. The thing about these, and I assume it's the same for pretty much any mirror, was that learning how they come apart. So basically the large part of the mirror body bolts with self-tapping screws to this part of plastic, and then there is a spring-loaded tube that holds the two bits of plastic together, and this second bit of plastic again is held on with self-tapping screws and a clip onto the regular bodywork. So it's a question of twisting the mirror around until you can get it at a point where these holes are exposed, and then you can take the thing apart. So you can see on this one I pulled the glass out. Actually I didn't need to do that, but it wasn't until I started poking at them that I realised how to get the things apart. So now understanding how they go together, I got rid of the part that would normally attach to the car, and this bit of plastic here is a prototype for the piece of aluminium that I'll machine out to hold the mirror instead of that, and then we'll weld some plates onto the A pillar of the car to go either side of this that will hold it onto the car, and hopefully that won't be too flappy. The plate itself I'll 3D print some sort of section to go over this to cover up the aluminium plate and make it look a bit more attractive, rounded off, shall we say. So I wasn't really aware of how these things came apart before. I think it seems to be easier to take production car mirrors and modify them for use like this than I expected it to be. Actually, I thought I was going to have to gut the entire contents of the mirror and possibly put it in a new housing altogether to make this work, but this looks like it will work. This is another thing I've sourced recently, is a electric heater from AliExpress, very cheap and nasty. The label on it says that it's rated for 12 volts at 400 watts, and I've tested this and it's actually accurate, surprisingly accurate. When you initially turn the thing on, it draws 500 watts, and then as the heater elements come up to temperature and self-regulate, we get down to 400 watts, and so it gets pretty hot, but the fan inside it is pretty pathetic. May do something about that at some point. This type of fan is not really the correct fan. You'll notice that it's not a squirrel cage fan, it's just a regular centrifuge, regular fan, and so which is not very good in this application, but for its purpose, which is just to show that I've got something to demist the windscreen, that's good enough. This is the first test I did on printing a duct to connect the printer, connect the heater, sorry, into where it's going to go on the car. This has been printed in ABS carbon fibre on the big printer. It came out, I guess, surprisingly well. Considering I haven't basically done any calibration or anything on the printer. I need to step back and do some more calibrations and get myself organised. You'll notice up here you can see that it's melted, because at that point I didn't have any cooling on the printer at all, which is something I'm in the process of fixing now. With this bit, which is the blower duct to go on the 3D printer. This is printed in polycarbonate carbon fibre, and hopefully we'll be able to deal with the temperatures that the printer runs at. The first one of these that I made was done in PETG, and it melted quite spectacularly under the temperature, which was not surprising thinking about it. This is the duct to go behind the radiator on the driver's side. This one has been printed in ABS carbon fibre. This is the first proper big print to come off the printer since I changed the hot end and the extruder on the machine to the Goliath hot end from Veg 3D with their extruder, water cooled. I'm pretty happy about how that's going so far. It's definitely an improvement over the previous arrangement that I had. I wasn't very happy with the old extruder. Sorry, not extruder. The extruder was fine. The hot end was a bit of an issue. To me, it felt like anyway. I made a mistake on this part in that I stopped it. I thought it had finished when I looked at it, and I stopped it, but it actually hadn't finished. When I looked at it on the webcam, it was it had paused because it had run out of filament. And there's between the part and the support necessary for it, you can see some of the supports that are left over here. There was over 2.5 kilos of plastic went into that. Right now the part once the supports have been removed, we've got about 1.6 kilos of plastic there. It doesn't feel excessively heavy for its size, bearing in mind that that is 600 millimeters tall, that part that you're looking at. I printed off the part to finish it off, so I'm going to glue those two bits together, and I will reinforce it on the back with some more plastic printed in the other direction, and then bond all that together. Because being that it's ABS, it's not very difficult to glue it, unlike some plastics which are extremely difficult. In the background, this is the big 3D printer. I don't think I'm going to talk about that in this video, but there's work ongoing on that to sort out the cooling system and get going again, and really start knocking out the parts. Without going into too much of the technical details of the 3D printer, but the 3D printer's the critical path on the project. Is that I need to get this thing running a lot to produce the bits of plastic that I need for the car to finish it off. If we look at this single part here, this was 2.5 kilos of plastic printed in 22 hours. I'm going to make an effort to get the amount of plastic that the 3D printer extrudes up, because that primarily affects how fast I can print parts. So if you look at this particular part here, the majority of it was printed at 60 millimeters cubed a minute. I think I can get that higher with some modifications to the extruder, which seems to be the limiting factor. Nothing else is getting in the way. if we look at the it does look a bit scratchy where I've been cleaning it up. It doesn't really matter because no one's going to see it. But looking at this, it's printed at a 0.6mm layer height on a 0.8mm nozzle with a 1mm width. So we can, that's one of the ways in which I can squash out a lot of plastic from the 3D printer. The idea on these ribs that you can see here is that obviously the 3D print is strong in bending in one direction but weak in another, or relatively weak. So I've put these ribs in to stiffen it up in that direction, and then I've left holes through the middle of the ribs. The idea with that is to put composite toe through the holes and hold that all in with resin. So if the component is attempting to bend in that direction from an impact on that would come on the other side from what you're looking at here, it's going to have to stretch the toe to do it. Unfortunately, the holes in this stage, in this part I've left, are not big enough. I've been able to get a welding rod through 2 of the 3 holes, but fundamentally I think I didn't leave the holes to be big enough. So I think this having felt the part in my hand, I think is quite strong enough to use as it is, so I will use it as it is. And if something we may come back to in the future and reprint again once we've got the printer calibrated properly and learnt more about how to do it. But at the moment we've got a serviceable part, so we'll move on. That's about it for the moment, so I'll stop the video. Cheers.